castle where the digital dreams come alive. CESCG takes place from May 1 to 5, from visualization to the virtual space. Scientific sessions take their place.
Hello, I am Pavel Dubas from Brno University of Technology, and goal of my work was to create a big image of the floor or some material to localize in some query image using neural networks and approximate search. I'm using videos of some floor or some materials, including some very large ones, and sampling them using OpenCV and other libraries to create small frames of them or small patches, and then using image stitching to create a very big picture. Then using neural networks to train a model that create embeddings to create a big database of embeddings that we can localize the query image we take. There are a few steps of this work. The first one was to create some dataset of material. The best one I created was this giant Persian rug. It was created by using a device that goes up and down, collecting the images from the material. The results were very good. That's the big image created by this approach. There were datasets created that are from small images or the big ones. The main dataset used was 520 times 520 of resolution that is used in ResNet. First step of this work was image stitching. The input of this stage is video frames, when the output is a large stitched image. For this task I used the conventional methods such as SIFT and then FLAN for matching of the features. There are some properties I defined to simplify the task of obtaining the videos. The main ones are the ground should be parallel to it, so there aren't many differences or convolutions in the scanning process. And this technique is not very applicable to all frames. I was trying even in the dark or using some flashlight images, but it didn't work for normal stitching algorithms. In the future, I was planning to use the localization of the capturing device to help with the stitching. The model training, I was using small patches of the images created in the dataset section. The small pictures are created by cropping out the middle part, and I apply some homography before giving it to ResNet. The batch size was 256. That's the parameters for the network. The H part is the homography applied, like the camera movement. I simulated to make the network not care about the camera and how should we take the picture when we give it the query image. The next part was to create a large embedding database of the big picture. I was using PICE library to do this. When the model is trained, I then use some step to patchisize the picture and then create one big index for this image to then use it to localize the image. These are some results for the localizing process. On the left side, we have the image we want to localize within the great picture, and the paths where the potential hypothesis of the localization for small part of the query picture is. The dotted ones are the potential hypothesis, and the final solution is the big red bounding box. I use average or other metrics to get the distance between the query images and the big one, and the smallest distance between them is the final localized image. homography refinement, I used template matching to do this. It's a very simple method to move the potential hypothesis for the homography using template matching. So this was the hypothesis for the one middle point for the big picture, but it wasn't very correct. So using template matching, we can almost exactly tell where the real point should be and move it to that side. And using that, we can pretty much locate the picture very nicely. I used some lines so you can tell where is the potential point, so you can navigate if it's correct or not. And that's my presentation.
Thank you for your presentation. So now it's time for questions.
Thank you for the presentation. So I have one question relating to this template matching. It seems that it would not work when the query image is rotated with respect to the original image. So is that true, or is there does it consider rotation as well?
This approach works when you create a big database for the big image and then localize it using the approximate search. You have to create index and then localize it. It should fasten the localizing, but you have to take some time to create the index first.
But the template matching that you showed on the previous slide, right? You already get a match, and then you refine the position of the match, as I understand it.
Yeah.
But would this work if the image is... Because now I see that the query image, does it work when it's rotated?
This approach works when the homography is almost right. If it's rotated or skewed, it doesn't work. This optimization is applied just when it makes the distance smaller. Otherwise, it takes the original one.
Okay, thank you. And then I have another question is, so what is the potential application or motivation to do this? What are some potential uses of this, finding this image in the larger one?
When we have some large rooms like this conference room, we can take the pictures from above and then throw a pen, for example, and take the picture of it and then try to localize it within the big picture using something like this.
Okay, thank you.
Have you considered using some other methods for local feature matching, like, I don't know, superpoint?
Yeah,
surfs and...
the image stitching was done very early in the development, so I was using some traditional methods, but as time goes on, I should use some smarter methods to do the stitching. Then it should work faster and the process should be smoother.
Okay, thank you. So maybe someone figured out another question. Okay, if this is not the case, I would like to thank all the speakers of this session again.
Swim to the beach where the pixels play, from rendering to VR. It's a pixel away.